Hello, everyone. I'm Matias Vara, and this is...
Hello, I'm Erwann Roussy from Savoir-faire Linux, and I'm a maintainer of the SEAPATH project.
I'm working at Red Hat. In this presentation, we're going to present both. The first half, I'm going to talk about the use of bootc for deployment of SEAPATH, and then Erwann will continue the other half. So let's start it. So I would like just to introduce myself. I'm Matias Vara. I'm software engineer at Red Hat, and I'm mostly interested in virtualization and operating system also. And the goal of this talk is about the use of smash mode to ease the SEAPATH deployment. Bear in mind that this is a proof of concept in which I have been working last year. This hasn't been streamed, and actually the idea of this presentation is just to give you more information about the proof of concept. And just to say that there is still a lot of things to discuss on this proof of concept before it can be streamed. So just to have an idea when we talk about the SEAPATH node, what exactly we have a host which could be x86. This is what I haven't tried, and it's quite hard to talk with this. And then we have a Linux kernel with a few patches to make it RT, so real time. We have also a few patches in the KVM, which is a hypervisor, to make it real time too. In user space, we have a few packages like QEMU, Ceph, Pacemaker, and another one. This is not exhaustive. There are more packages installed. And then on top of this, we have the virtual machines. But in overall, this is what we have after the deployment of what we call SEAPATH. So when I started to work on this last year, I was mainly based on the CentOS distribution. So I could separate the process to deploy SEAPATH in two steps, let's say. We have a first step in which we have a quick start file in which we generate some ISOs. And from those ISOs, then we deploy in the host. So this is the first phase in which we do the installation. And a second phase in which we run some playbooks which are hosted in some Ansible repository. This is the GitHub repository. And those playbooks rely on something called inventory, which can contain some information like some IP, some particular configuration of the host. And this is the second step in which we do installation, because this Ansible also installs some stuff, but also configuration, because we're going to set up some parameters. So that was the context last year when I started to play with SEAPATH. And one of the ideas we have was, can we leverage bootc containers in this context? And this is what I'm going to talk in the next slide. What is exactly bootc containers? So are containers that can boot as operating system. So it doesn't include only yes, the package, but also the bootloader and the kernel. And they are stored, generally they are stored as image in some register. The register could be local or remotely. Could be used to deploy bare metal hosts, as I showed you before, or virtual machines. They propose an immutable file system in which only those directories are writable. And these images that are deployed can be adapted in a all or nothing manner, let's say. If something happened in the image and cannot be, for some reason updated, we could add rollback automatically. To do all that, we rely on a command called bootc, which has simple syntax to the updates and the rollback. So if you come back to what I proposed, what I showed you before, the proposal was, well, let's define a container file, call it SEAPATH container file, which is going to rely on a CentOS, for example, CentOS, bootc Streamline. And from this container file, we define all the package that we need, probably some configuration also, and from there we generate an image. From this image, then we push it in some register, either locally or remotely, and then we do the deployment of the SEAPATH host by relying on this register. And then we have, this is the step number 3, we still have a phase in which configure those hosts, and for that we also rely on some playbooks here, but these playbooks are not going to install anything on the host, they will do only configuration. I would like to mention also a 5th step in which any change in the container file, in the original container file, for example, if you want to install a new package or whatever, then we rebuild the image, push to a register, and we have just to do something like bootc update or something like this in each host to get the new image. We have to have also in mind that these images are like container. So they are not strictly image as we can think. They are things built by layers. So if, for example, we need to start a new package, we're not going to rebuild the whole image, only the layer that corresponds with that change. So I will go through these steps just to give you more concrete examples about exactly what that means, all those steps. So in the definition, we have a normal container file. It's just that the front is rely on an image that is from bootc, which is going to contain the bootloader, the kernel, and so on. Then we will have some installation packet, which were previously in the Ansible, and then I move it here. But this container file also is parameterized because, for example, some configuration that was in the Ansible, like the number of cores I'm going to use to isolate from the Linux scheduler, instead of using Ansible to configure that, I will do it here. And this is the lines. I mean, I wanted just to show this, just to show that we can do some configuration on this step. It could not, I mean, it could be something else. This could be also moved to the Ansible, but yeah, I mean, the idea was to show that it was possible to do. So then we are going to build the image, which is just a normal podman command, which first build, and then we push to a repository, a remote repository. Here I want just to highlight, as I mentioned before, that the container file is parameterized, and it's here where I pass those parameters. So I am like specifying in which host I'm going to build, or the characteristics of the host that this image is going to be deployed. And then in the third step, this is the deployment. We have several ways to do the deployment. You can either boot up the host and then modify the command line of the installer to fetch the image from some repository, or you can just, as I show you here, build an ISO that relies in this ISO that is going to contain also a kickstart file, which at the end is going just to fetch the image that you just created from the repository. And then, well, what I did, and this is just because I was playing with this, it was a proof of concept, and once I have deployed the host, I wanted just to try that everything, I mean, I wanted to just also configure those hosts, so I was running the cpath mine playbook and also the deploy VM cluster playbook to see that it was working. This Ansible that I'm using here has been modified to not install anything. So I let only the task that was configure something. And just to have an idea what exactly the update the system step means, when some content, if the image for some reason has changed, so for example, we change the image, we push a new version of the image, we have to run bootc update in each host just to fetch the new image, and that is automatically done. Yes, so if you want to do it yourself, you have the repository. As I mentioned before, this is a proof of concept that I worked last year. And what I did was to rely on the status of the Ansible repository at that moment. So if you clone this, you're going to clone the Ansible, for example, repository from the commit that I have been using, which is out of date. But at least you can have a test, about what how the whole procedure works. This what generate is a CentOS Streamlining image, which has all the package for SEAPATH and can be configured with the Ansible I mentioned before, and create a virtual machine too. So now is the turn of Erwann.
Thank you, Matias, for this bootc proposition. On the next part of this talk, I will present to you the Ansible tool, why we use it on SEAPATH, and what it does. So the very idea behind the Ansible tool is the philosophy of infrastructure as code. And I will try to explain you what it is with a small anecdote. In the early years of SEAPATH, we had a demo to do at RT, to be honest, and we bring up the 3 machines to build the SEAPATH cluster. We're starting to do all the configuration. There are many layers, as you saw in the beginning of the presentation. And during the whole afternoon, we weren't able to make all the machines works. And this demo was absolutely failure because we weren't able just to set up everything. There was always a small problem, the small things we didn't have thought about. And after going out to the demo, we just asked ourselves, how can we do it in another way? How can we avoid that? And the response is infrastructure as code. The idea is how to ensure that your setup is correctly configured, how to reproduce, and eventually how to scale when you start with that. So what is infrastructurized code? It is code snippets that you write to describe your infrastructure. So it's a declarative approach in text files that is fully reliable, reproducible because you can replay many times the same configuration, and that also allow versionings because it is only text files. So that's the philosophy, and the tool we chose for that is Ansible, which is a machine fleet management tool maintained by Red Hat. It is widely used in the cloud infrastructures today, but not so much in the energy. And Ansible relies on 3 concepts, 3 types of files. The first one is the inventory. It's the list of the machine you have. It's basically the where. Where do you want things to happen? With these machines, you have variables that you will be able to use to configure the machines. On the second time, you have the role. The role is a set of tasks. So it's what you want to do on your machine. And it uses the variables defined in inventory. And at last, you have the playbook, which just to take the 2 things together by telling, okay, I want to apply this role on this machine in this order. And we provide all of that on SEAPATH. I just want to mention that all these files are text files, so human-readable files, not binary files that you don't understand. You can open that with any text editor that you want. How do we use Ansible on SEAPATH? So I just take a bit of time on this schema. So we have 3 distributions on SEAPATH, the Yocto one, the Debian one, and now the CentOS one. And the first thing we want to do on SEAPATH is installing an ISO, installing an image on a cluster. On Debian and CentOS, we start with an unconfigured Debian and CentOS image. We install them, and then you have a full configuration, ISO configuration step to do with Ansible. And this is this part that Matias proposed to replace eventually with bootc. On Yocto, we do a compilation of an image starting from a standard Linux kernel, and we do all the configuration of the ISO inside this compilation step. But then, when you start with that, you have to put all your machines together and start to have a SEAPATH infrastructure working. And this is also done by Ansible. So it's another task in our Ansible playbooks. It's the infrastructure deployment. And when you are there, you have an iso-functional CPaaS, no matter the distribution you choose. And eventually, you want to do some management on this cluster, which is also done by Ansible. So first of all, how do we deploy the infrastructure using Ansible? What is the idea? As I said, we provide roles and playbooks on CPaaS to deploy your CPaaS infrastructure. We have splitted the works in several roles, so you can choose the one that fits for you. Let's put some examples. For example, the time master role set up all the time synchronization, but only do that, the PTP, the NTP. The safe ADM role deploys Ceph with a specific method, but don't deal with time master with a time synchronization or anything. A more interesting one is the hardware customization Velotech role, which do some configuration related to the network card of the Velotech machines specifically, and that should not be applied on any other machine. So on CPaaS, we provide default playbooks for the most standard use case, like for example, setup networks that will apply many roles, but are only for standard usage. And if you want a more precise usage, you will have to write your own playbook at a time. How do we configure our CPaaS infrastructure? On Ansible, we have several variables defined in the inventory, as I said, and we define many variables for you in CPaaS that you should fill regarding to your needs. Let's take some simple example. ISOL CPU is the list of CPU reserved for the real-time virtual machines. The CFOSD disk is the disk of our Ceph. The cluster IP address is just the IP address of the machine on the cluster. So these are standard, mandatory variables on Ansible. We also provide extension points in Ansible. So if you want to entirely redefine a specific point of your configuration, or if you want to have extended possibilities on Ansible, we provide these points, so you don't have to really rewrite a playbook, rewrite a role yourself. Some example, there are many other. The custom network on NetDev allows to completely redefine the network of a machine, so don't rely on the standard CPaaS network. The upload files is just for uploading files on the machine you want, no matter what it is. The extra CRM CMD to run are a pacemaker command to run on top of the cluster when it's built, so that you can have more resources running on CPaaS. And you have the full documentation, on the Ansible Galaxy, or CPaaS Ansible Galaxy, if you want to look for all these variables. So it looks like that in the end. On the right, you have the inventory with 2 hypervisors here. At least you have 3, but I don't have so much place on the slide. All the variables, standard variables on CPaaS. And you can use the CPaaS setup main playbook, which is the basic use case of CPaaS and calls most of the roles in a standard way. If you want a more advanced use, you will have to write your playbooks. So it looks like that. I just put a small snippet here. So I want to call these specific roles on these specific machines. Now, our CPaaS infrastructure is deployed. How do we manage this CPaaS infrastructure? First, we want to deploy virtual machines. So the very basic way of deploying a virtual machine or CPaaS is providing one XML and one QCO2 file. And you can do it by filling this inventory. There is an example on the CPaaS repository. And it will deploy the VMs and handle the deployment on the cluster, so with a high availability. So you don't have to do it yourself. If you want a more advanced usage, we have also provided templated libvirt XML files, which are the way to describe the hardware, the emulated hardware of your virtual machine. So this is also an example, I think the default example for the VM on CPaaS with some more additional variables like 6 gigabit of memory using the CPU 4, 5, 6, 7 and so on. The role, so the deployment playbook of CPaaS already handled the Jinja2 XML libvirt XML file. And we have 2 main examples. The guest.xml.g2 is a standard VM that we use for the CI and that should fit the most basic needs. And we have also done the same type of file for the IBB SSA 600 software VM. So again, you have the full documentation on the wiki. And we are, of course, open to integrate more VIDs on CPaaS. So if you wish to have your VID integrate and merge directly in the CPaaS code base, it could be done. I put just the mailing list of CPaaS. Don't hesitate to ping us. Now, last part, how about scaling? If we want to deploy more, how do we do that? First of all, we can deploy multiple VM at a time with the same type of playbooks. Here, 4 VMs that I deployed with some also standard variables on CPaaS. You can use location rule to choose the machine on which you want your VM to run. Collocation, so which VM should run with which VM on the machine. And you can use the same playbooks as before to deploy all these VM at once. Again, you can have the same deployment on your lab and on your cluster because everything relies just on this inventory. The rest is CPaaS playbooks and roles that are already done by the CPaaS community. If you want to deploy your application inside the virtual machines, some virtual machines come fully configured. That's the case for the ABB VM that you just deployed with the XML files that I provided. If you want to deploy your applications, I would let RTE describe that. Last year at LF Energy Summit, they have done some quick example of how they do that, so deploying Dockers inside virtual machines. And they also do that by creating more playbooks to integrate into the VM to deploy the applications. And last, how about multi-infrastructure deployments? So here I talk only about one CPaaS cluster, but if you have multiple substations, for example, currently the philosophy of CPaaS is to use different inventories. If you have different CPaaS infrastructure, you use different inventories. The really good point is that you should always have to write your inventory for one substation, one infrastructure, and if you use all the configuration and extension point that we provide, you should be able to not having to touch the Ansible playbooks and roles and just rely on the inventory. Currently, there is no idea in CPaaS to handle multi-cluster or multi-substation in one inventory, one CPaaS inventory. So thank you for all. I just put some links on the project on the bottom of the page if you need. And if you have some questions, I think we have a couple of minutes for questions, either from me or for Matias.
Thank you for your session. One question is the guest machines is not needed that you can be able to access with Ansible or not. So it depends on the vendor.
The Ansible is running on a specific machine, so on a configuration machine like a laptop.
If you have now a full system, then you have 10 virtual machines, yes? And this virtual machine is not a must that they must be accessible by Ansible. So it depends on the vendor. There's not the philosophy that this also should be accessible via CPaaS to have control of these local machines.
Yeah,
you know what I mean?
Yeah, I think I know. Some of the virtual machines will be accessible by SSH, and if they are, basically you can access them with Ansible. But that depends on the virtual machine you have. For example, the ABB is not accessible with Ansible, but the virtual machines that RT is doing on their own are accessible because they want to do that and they control the VM. So it's not always the case, of course.
So you need your own bootstrapping, depends on the virtual machine then?
Yeah, okay. Exactly.
No?
Hello. If I, as a vendor, want to integrate a virtual AD in a virtual machine, how much effort do I have to put in it?
Dependent on the base you are already using for the virtual machines. So here we are using QEMU and libvirt files to deploy the virtual machines, and it was basically already the case, for example, for the ABB VM. So the challenge was just to have the correct configuration in CPaaS, which doesn't take so much days of work, like something like that. If you have a fully other technology, for example, not QEMU virtual machines, it would be harder, of course, because you have to rebuild some things. Okay, one more question, go.
Hi, thank you for the presentation. I have a question. I've seen on the configuration files that there is configured pass-through, a PCI pass-through. This makes exclusive the usage of a particular device to a particular virtual machine, correct?
Yeah.
So if I would like to have a fully redundant system, I need to put two PCI Express devices that are routed to two different VMs. Is that correct?
It depends on the redundancy you choose. If you speak about hardware redundancy, so hypervisor level, or network redundancy. So it's two different things. But yes, if you're speaking about hardware redundancy, you would need one link per hypervisor, so the VM can migrate on the cluster.
Clear. Thank you.
You're welcome. Okay, thank you, everyone.
Thank you.